In this presentation, I'm going to talk about sampling distribution and central limit theorem. So what's a sampling distribution? It's a probability distribution of a statistic obtained by a large number of samples drawn from a population. So instead of looking at individual raw data, we will be looking at statistic of those samples. So what is a statistic? It's any numerical measurement related to a sample. For example, sample mean x bar, sample proportion p hat. In this lecture, we're going to specifically talk about central limit theorem for mean. It is conclusion of a sampling distribution of x bar from any population that has a mean of mu and a variance of sigma squared when we take random samples of size n. The sampling distribution of x bar is approximately normally distributed with the mean to be the mean of the original population. The variance will be the variance of the original population divided by the sample size n, and a standard deviation will be a standard deviation of the original population divided by square root of the sample size n. We're not going to prove these, but we're going to show that they seem to be valid through some examples. Consider a four-sided fair die that its sides are numbered 1, 2, 3, 4. We're going to find the mean, standard deviation, and variance if we roll this die once. We're going to list all possible samples of size 2 if we roll this die twice. Then we're going to find the mean of each sample, and we're going to construct a table that contains the mean and the probability of each mean. Then we're going to use discrete probability distribution to find the mean of the means, the standard deviation of the means, and also the exact value of the variance of the means. So to find the mean, standard deviation, and variance of the, rolling it once, the numbers 1, 2, 3, 4, we're going to place those in a list. We're going to do basic computations, and we conclude that the mean is 2.5, the standard deviation is 1.118, and the variance is 1.25. Now we're going to consider all samples of size 2 with replacement with these numbers. So that means we can have 1 with 1, 1 with 2, 1 with 3, all the way to 4 with 4. It's like rolling it twice. So these are the list of all possible outcomes. Now we're going to find the mean of each of these samples. So for example, the mean of 1, 1 in yellow will be 1. the mean of 3, 4 in pink would be 3.5. And the mean of 4, 2 will be 3. And so on and so forth for everyone. Now we're going to make a table that contains these means and the probability of each mean. So we had a mean of 1 with the probability of 1 over 16, the mean of 1.5 with the probability of 2 over 16, and so on and so forth. I did not reduce the probabilities, so if we were to add them all together, the denominator would be the same, and we should get 16 over 16, which is total probability 1. Now we're going to place x bar and the probability of x bar in list 2 and list 3, and we can use our TI calculator to find that the mean of the means is 2.5, standard deviation of the means is 0.791, and the variance would be 0.625. This is the variance of the means. Now let's use these results to verify the conclusion of central limit theorem. The mean of the original population was 2.5, which is the same as the mean of the means. The variance of the means is the variance of the original 1.25 divided by sample size 2, which is 0.625. Now let's do the same thing, this time with 5 numbers, 2, 4, 6, 8, and 10. We're going to use our TI calculator to quickly find the mean and the variance. We're going to list all possible samples of size 2 with replacement. Then we're going to find the mean for each sample. We're going to construct a table that contains the mean and the probability of each mean. We're going to draw probability distribution histogram using the mean and the probability of the means. And we're going to show that the probability histogram has a shape of a normal curve. So using our calculator, we get the mean to be 6, standard deviation to be 2.828, and the variance to be exactly 8. So we simply put the numbers in a list and then we do our computations. Now, all samples of size 2 with replacement for this population would be this list, this table. So you can have 2 with 2, 2 with 4, 2 with 6, 2 with 8, 2 with 10, all the way to 10 with 10. Just like our first example, we're going to find the mean of each sample. Now we're going to make a table for the means and the probability of each mean. So we had a mean of 2 and the probability of that was 1 over 25. We had a mean of 3 with a probability of 2 over 25, and so on and so forth. Now to draw probability histogram using x bar and probability of x bar, so all the x's will be like midpoints and all the probabilities will determine the height of each bar. As you see, it is very symmetric looking histogram. Now, if we draw a curve on top of this and extend it on either side, we're going to get a shape of a normal curve. Now we're going to place the x bar and probability of x bar in list 2 and list 3, and then we're going to find the mean, the standard deviation, and the exact value of the variance. And then we're going to use these results to verify the conclusion of the central limit theorem. So after we enter the numbers in L2 and L3, we do the computations and we get the mean of the means to be 6 and a standard deviation of the means to be 2. And basically we're going to square this result to get the variance of the means to be 4. Now, the conclusion of the central limit theorem says that the mean of the means is the same as the mean of the original, which is 6. The variance of the means is a variance of the original, which was 8, divided by our sample size n, in this case 2. So 8 divided by 2 is 4. So that verifies the conclusion of central limit theorem for means. Now in this example, we're going to use sampling distribution of x bar with sample size 16 from a population that has a mean of 375 and a variance of 100. So the mean of the means will be the same as the original by central limit theorem, and the variance of the means will be variance of the original divided by our sample size. The variance of the original was 100. The sample size was 16. So we end up getting 6.25. This is the variance of the means. In this example, we have a sampling distribution of x bar with the sample size 10 selected randomly from a normally distributed population with the mean of 82 and a standard deviation of 7.5. We want to find the mean of the means, and we want to find standard deviation of the means. Now, by central limit theorem, the mean of the means is the same as the mean of the original, so that would be 82. And a standard deviation of the means would be a standard deviation of the original, 7.5, divided by a square root of the sample size, in this case, a square root of 10. And that value is 2.372. I hope this presentation helped you understand what central limit theorem is and how is it going to work with the samples and the mean of those samples.